All right, so we are focusing today strictly on solving by substitution. Now, sometimes solving by substitution is an appropriate time and sometimes it's not. And so let's take a look at these three different systems of equations that we have here in number one, because there are some systems that are good candidates for substitution and some that are not. And so let's take a look at this first one. And it is 2x minus 5y equals 18. Okay, and then the other one is y equals 2x minus 10. Now this one, I will tell you, is a great candidate for solving with substitution because it has that right there. It tells you the exact value of y in terms of the x. So y equals 2x minus 10. It tells you what y is. And so you're like, yeah, absolutely. This is a good system to solve with substitution because we can take that y equals 2x minus 10 and just substitute it for y right there. That makes it super simple. Okay. Now, let's take a look at this next one. The next one says x plus 5y equals 4 and 3x plus 10y equals 10. Is this a good candidate for solving with substitution? Well, actually it is, because if we take, whoops, sorry about that. That's not what I wanted. I wanted to highlight that. If we take x plus 5y equals 4, we can solve that one really quite simply in terms of x. So let me show you real quick. X plus 5y equals 4. We can solve this one for x simply by subtracting 5y from both sides. That cancels out on that side, leaving us with x equals 4 minus 5y on the other side. So we can easily substitute this for x in the other equation. So this one, that's a good candidate for using substitution. Now, will all three of these be good candidates for substitution? Not necessarily, because if you look at the third system, 2x plus 3y equals 11 and 3x plus 2y equals 4, we would have to do a whole lot more work to either one of these equations to solve it for one variable in terms of the other. Can it be done? Well, yeah, but it's not an easy task to do. So we would spend a lot of time just solving for one variable in terms of the other to do that. So that's going to be a better candidate for a different method that we'll learn about later. So don't worry about it. So these two, the first, these are easy substitutions to make. But the third one, there's too much work. There's too much work involved to make substitution a viable alternative. It can be done. It just wouldn't be much fun because we want math to be fun. So let's take a look at substitution like we learned yesterday or in the previous lesson. So we're going to use the substitution method to solve this system of equations. Okay, so first of all, let's look at which of these equations can we use for the substitution. Well, the first one is 2x minus 5y equals 18. And then the next one, it gives us that nice substitution where we can say, all right, well, y is 2x minus 10. We can take that and substitute that in for y in the other equation. Now, please make sure that your book is open to page 413 and you're following along with me. If you don't have your book, make sure that you're writing this down in a paper notebook so that when you need to transfer your answers into the forms document, it'll be an easy task for you. All right, so now we're going to take this equation right here, the 2x minus 5y equals, well, there we go, equals 18. And we are going to substitute the y with 2x minus 10. All right, so that part gets substituted. So 2x minus 5 times 2x minus 10 equals 18. Okay. Now we substitute, or not substitute, I'm sorry, we distribute. It ends with the same sound. We're going to distribute negative 5 to 2x and negative 5 to negative 10. So that our next step would be, we keep this 2x just as it is, but negative 5 times 2x is negative 10x. And negative 5 times negative 10, and negative times negative is positive, positive 50 equals 18. All right. Now we can combine like terms, 2x and negative 10x. And so that would be negative 8x. Oh, come on, draw the x. There we go. Plus 50 equals 18. Now remember, if you have any kind of questions as I'm working through this, feel free to just type a question mark into the chat and I'll stop and pause the recording and address your question. All you need to do is type a question mark. All right, so we have a negative 8x plus 50 equals 18. Well, our next step is to subtract the 50 because we're trying to get the x variable by itself. And this is the next step in that process. 50 minus 50, those cancel each other out. Let me scroll down here. And so we are left with negative 8x equals, let's see, 18 minus 50 is negative 32. All right. My next step would be to divide both sides by negative 8. All these algebra skills that you learned in previous lessons are coming in handy now. And so when we're all done, x ends up being negative 32 divided by negative 8 is 4. So we have found what x is. Now, since we have found how much x is, we can go back and substitute that again into this equation here, where it was y equals 2x minus 10. Well, we know that x is 4 now. And so we can turn this into y equals 2 times 4 minus 10. And 2 times 4 is 8, so y equals 2 times, I'm sorry, 2 times 4 is 8. Okay, 8 minus 10. There we go. And 8 minus 10, if you remember what subtraction is, it's adding the opposite. So you say, okay, that's plus a negative 10. And 8 plus negative 10 is negative 2. So y equals negative 2. There, we have found our x, we have found our y, and we can substitute those back into our equation to check to make sure that that is correct. But our ordered pair, our solution here is 4 and negative 2. And there is our solution. 4, negative 2. In the interest of time, just want to make sure that we get through everything or as much as possible. Remember, all you have to do to substitute is to take these two values, your x and your y, substitute those back into the original two equations in the system, and make sure that those equations are true. For example, 2 times 4 is 8, minus negative 2 times negative 5 is positive 10. So that would be 8 plus 10, that equals 18. So you can see how those will satisfy both of those equations. All right, let's continue on to the next question. Question number 3. Consider the following system of equations. Now, this one isn't quite as handy as the one before it because, as you can see, it doesn't give you a solution for y or x right away. So the first thing you have to do is, like they say here, solve the first equation for x. Okay, so that's exactly what we'll do. So we're going to solve the first equation for x because it's nice because the x is all by itself right there. So it's like a one-step deal to solve for that. So I'm going to go over here and do that. So x plus 5y equals 4. All right, I want to get x by itself. Solving for x, I'm going to subtract 5y from both sides. So these cancel each other out, and I get x equals 4 minus 5y. Okay, now, there we have it. I'll just put that for x equals 4 minus 5y. Now we can use that substitution to solve the system. Okay, because we know what x is, we can use that x to substitute in for the other equation. And so x is 4 minus 5y. So I can use that anytime I see x in the other equation, which, down here. So let's rewrite this one. 3 times x plus 10y equals 10. Okay. Remember what x is. X is 4 minus 5y. So this will become 3 times 4 minus 5y. Just substituting. Plus 10y equals 10. Okay. Now, going to distribute my 3. 3 times 4 is 12. 3 times negative 5y is negative 15y. And then we just bring that 10y down, equals 10. Okay, well, now we can combine some like terms. We've got negative 15y and positive 10y. Those are like terms. They can be combined in the next step. So first we'll bring the 12 down, and then negative 15 and positive 10 combine to make negative 5y. And that would equal 10, because we just bring that 10 down. Now I need to try to get the y by itself, so I'll subtract 12 from both sides. These cancel each other out, and I'm left with negative 5y equaling 10 minus 12 is negative 2. And then my last step, I believe, it would be to divide both sides by negative 5, negative 5, and those cancel each other out, and y equals negative 2 divided by negative 5. That's going to be positive 2/5. Or let's see here, 2 divided by 5 is 0.4. So depending on what's going to work out best, 0.4. Okay. Now that we've found what y is, right? We found what y is. We can go back and substitute that in to the equation for x, because remember, we took this equation and turned it into that one to solve for x. So x minus 4 minus 5y. So x equals 4 minus 5y. And we determined that y is 0.4. So x equals 4 minus 5 times 0.4. We could use the fraction 2 if we wanted to, but either way, 0.4 times 5 is 2. So this becomes 4 minus 2 equals x. And so that means that x is going to be 4 minus 2, which is 2. So now we have found both of them. We found x and we found y. Sorry, that looks like a z. All right. So our ordered pair, our solution will be 2, and 0.4. Now, if we want to make sure that that is correct, we would go back and substitute those back in. And I'm a little worried about that decimal because I want to make sure that it's right. So I'm going to go back to my original equation here, this one, and make sure that I'm not doing that one wrong. Let's see. 3 times 2 is 6, and 10 times 0.4. What is 10 times 0.4? Let's see here. 4 times 10 is 4. So 3 times 2 is 6. This one ends up being 4. So 6 plus 4, that equals 10. That's good. And we already know that it satisfies the other equation because that's what we did to find x equals 2. So we're good. Okay. The rest of this is just more solving by substitution. Now notice on this one, if you look at this, these both have y equals and y equals. And so you can, the way this one would get set up is like, okay, well, if y equals negative 2x plus 6 and y equals 3x minus 12, when we go to set this one up, well, we would say, all right, you can substitute whichever one you want. I'm going to take this one here, negative 2x plus 6, and I'm going to substitute it in the other equation for that y, so that when I write it out, it'll be negative 2x plus 6 equals 3x minus 12. Because remember, I took this one because that's what that y says it is, and I just substituted it for this one here. Now, all I have to do is substitute both sides. I have to solve both sides. I have to solve this equation for x in order to find out what it is, and then I'll solve for y. All right. Well, we are almost out of time, so I'm going to stop right here, and we'll talk more about